next session of ANSYS Workbench tutorials. In this session, we are solving buckling analysis of helical coil conical spring. We have already seen compression spring analysis in the previous class. Buckling has a more profound effect on compression spring as compared to conical spring. The reason is the geometry. If you have observed the previous video, you will understand that conical spring is more of a slender and a long type of a spring, whereas conical spring has a bigger base and a small top, because of which it becomes much stable when the load is applied on it. We will see the analysis now. We'll start with double clicking on static structural. I'll go to engineering data. Engineering data sources, general materials. Let's choose copper alloy as the material. I'll go back to project, update project. Next, I'll go to geometry, right click, new design modular geometry. Units, I'll choose millimeter, XY plane, look at. I'll go to sketching. I'll first draw a line and give it some dimensions. Say it is 70 mm. Now I'll go back to modeling. I'll click on new sketch. I'll go to sketch 2, sketching. Here I'll draw a circle. I'll give dimension to the circle and mark the distance between the line and the center of the circle. Say the diameter is 4 mm and this distance is 12 mm. Next I'll go to sweep option. Profile is the circle and path is the line, that is sketch 1. Scale I'll choose as 2 and twist specification I will change it to turns. Let me choose 6 turns and generate. You can see here, this is the helical coil conical spring. Now I need to slice this so that I can apply the boundary conditions. I will first select the circle, base circle, and click on new plane, generate. I will then click on slice. I'll choose the plane 4, apply, generate. You can see here the spring is now sliced. Geometry is done. I will go to model and double click on it. I'll first go to geometry. I'll choose all the solid parts and assign the material that we have chosen, that is copper alloy. I'll go to assignment and change the material to copper alloy. You can check by clicking on any random solid. It is all copper alloy. Next I'll go to mesh, sizing, relevant center. I will change it to fine and update. After meshing is done, I'll go to static structural and insert fixed support. I'll choose the lowermost portion of the spring, apply. Next I will insert force on the topmost portion. I'll change vector to component. You can see the direction is Y, but it is in the downward direction itself. So I will not attach negative sign. Directly I'll give a load of say 100 Newton. Then I'll go to solution and insert deformation total. Also I want to see the stress equivalent. Solve. You can see here, this is the deformation in the spring. We can animate and see the result. This is the equivalent stress generated on the body. Next, we'll go to eigenvalue buckling. I will drag and drop it over the solution. I'll double click on setup now. I'll go to analysis settings and change the maximum number of modes to 3. Also, I'll change include negative load multiplier to no. Then I'll go to solution and insert deformation total with mode 1, 2 and 3. I'll go to solution and solve. I'll go to total deformation, animate and see the result. This is the first mode of deformation. The load multiplier value is 3.17. I can multiply it with 100. The value will be 317.25 Newton. Next, I'll go for the second mode. This is how the spring is going to move or deform under this amount of load. And for the third mode, the spring is going to buckle like this. That will be under the effect of 17.216 into 100. That is 1721.6 Newton. So when you apply this amount of load, you will see a buckling like this on this spring. Conical spring is more stable under buckling as compared to compression spring because of this shape. You can see here the amount of coil material is more here and less here, and because of which the spring is more safe under buckling. So with this I end the session. I hope you have understood the process for analyzing a conical spring. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.